All right, today we're going to talk about section 5.1, which is talking about different angles in triangles and how we can classify triangles based on their sides and angles. So the first thing, a couple of things with review we've talked about before. But in order to do this, we need to remember that anytime we have a triangle, that we have 180 degrees in a triangle. And then we'll look at when we have sides of triangles, specific side lengths, it'll tell us that we can call a triangle something, and then based on their angles. So the first way we're going to talk about how to classify triangles is looking at their sides. And so there are three ways that we can name triangles looking at their sides. We can talk about it being a scalene triangle, which is looking at a triangle that has no sides that are congruent to each other. So we'll have three sides within the triangle that are all of different lengths. We could also talk about an isosceles triangle, which specifically has two congruent sides. And then also looking at the diagram with some vocab and talking about how the vertex angle in an isosceles triangle is the angle that is opposite of the base. And when we say the legs, then we're talking about the congruent sides in an isosceles triangle. And then the last way to reference a triangle by its name is calling it an equilateral triangle, which is when we have all three sides are congruent. Some of these names will always overlap with the angle names, and then others of them will sometimes we'll talk about that. And then based on the angles, there are four different ways that we can classify a triangle. So the first way with angles is talking about a right triangle. And this is a triangle that has exactly one right angle. And then we also know, actually, because they have to add up to 180, we know that the other two angles must be acute angles. We can also call a triangle an obtuse triangle, and that is a triangle that, again, can only have one obtuse angle, because if we have to add up to 180, we cannot have more than one angle that is greater than 90, which therefore means that the other two angles must be acute angles. A third way to classify a triangle is calling it an acute triangle, and an acute triangle is when you have all three acute angles. And then a very specific type of acute triangle is an equiangular triangle, and that is where you have all equal angles, which means that each angle equals 60 degrees. And so when we look at these triangles, there's a variety of ways that they can come in, and one of them could be something like this, where specific things are noted in a triangle, and we can solve for an x value, number one, but then we can also, once we have that x value, we can describe the name by its sides and by its angles. So why don't you take a moment, pause the video, and solve this one. So in this one, we know that all three angles must add up to 180 degrees. And so hopefully when you solve for x, you're able to get that x equals 8. So once we get x equals 8, we can plug that x value in, and we find out that this angle is 63 degrees, and this angle is 54 degrees. And then by looking at its sides, we have two of the sides that are marked congruent, so we can call it an isosceles triangle. And then based on the angles, because all three of the angles are less than 90 degrees, we can call it an acute triangle. We can also take a look at triangles within the coordinate plane, and we can classify it as well. So for the first part of this one, if we look at this triangle within the coordinate plane, classifying it by its sides, the first thing we need to do is actually have the side lengths. So again, why don't you take a moment and find the length of each side using the distance formula, and then we can decide what type of triangle this must be. So in this one, we find out that, and we don't need to simplify this one just for the purposes of this problem, but we find out that we clearly have a triangle that has 3 different side lengths, which means none of the sides are congruent, so we can justify that this is a scalene triangle. And then as far as determining if a triangle is a right triangle, we need to see if there are any perpendicular sides to create that right triangle. So in order to do that, we would need to find the slopes of all the sides. So why don't you go ahead and try to find the slopes of all the sides. So I would get that the slope of AC is -4. And the slope of AB is going to be -1/3. Actually, that is not correct. That's going to give me a slope of -2/7. And then we get a slope of +1/3 for BC. And we can see that there are no sides that are perpendicular, so this is not a right triangle. And so then we can apply this with finding different angle measures in triangles. So again, why don't you take a moment and solve for these 3 examples, A, B, and this 3rd example. So this first one, we see a couple different triangles. The first thing we're going to do is look at this triangle and find out that this angle is 80 degrees, which means its vertical angle is 80 degrees. So 2x must equal 100, which gives me 50. And in this one, we have 3 different triangles. And so for this one, x is actually intended to be right here. So in this first triangle, x is not a part of that. So this angle is going to have to be 50 degrees. And then in this triangle, the angle is going to have to be 35 degrees, which means x being this angle left, we would subtract those 2 from 180 and find out that x is, and I screwed up again. This is not 35. This is 25 degrees, which means that x has to be 105. And then in a one of the acute angles in a right triangle, you can draw a diagram for this one, or just know that when you have a right triangle, the other 2 angles must add up to 90. So one of them is going to be x and another one's going to be 1.5x. And so we can find out that both of the angles in the 2 measures of the angles, and it's 36 degrees and 54 degrees. And then the last thing is talking about an exterior angle theorem. And so I'm just going to draw a separate triangle to start here. So if we had a triangle, we'll call these angles A, B, and C. I can draw an exterior angle at any one of these. These are the 3 angles that are interior of a triangle. And then if I extend any one of these lines, I would have an exterior angle at that spot. So we know that in a triangle that we would have that all 3 angles inside the triangle add up to 180 degrees. We also separately would know that these 2 angles that form a straight angle would have to add up to 180 degrees. And we see 2 equations that have A and equals 180 degrees, and so we can justify that B plus C and D have to be the exact same thing. And so what this theorem is talking about is that D is an exterior angle of the triangle, and it's always going to have to be equal to the remote interior angles within that same triangle. So when I'm looking at number 11, that angle is 103 minus x. So 6x minus 7 is my exterior angle. Then it has to be equal to my other two non-adjacent remote interior angles. And then we could go ahead and solve for x. So at this point, why don't you go ahead and finish number 11, solving for x, and then solve these 6 down here and check your answers with your group.